Hey everybody. So thanks for joining us today. We have Spencer Kuhn with 3D Systems and Hawk Ridge Systems' own Matt Fisher with us today. They're both mechanical engineers who specialize in 3D scanning applications. And they are going to tackle our questions and show us what a few basic types of inspection cycles look like in the real world. And I want to stress that last part because this event was largely inspired by various webinars I've attended in the past where I go in hoping that I'll come out with a better understanding of the process, not just the product, and how all the parts fit together into a workflow. But in a lot of cases, I end up seeing PowerPoint slide after slide, endless bullet points, talking about how great their products supposedly are, and I just have to kind of take their word for it. And I don't really get to see the process, and at the end, I don't really have a clearer picture of what was involved than when I went in. So our goal here is to show you how these processes fit together, what's involved, how much time they take in the real world, how easy is it to implement a legit inspection process in your company. Is it something you need to create a specialist role for, or can this be handled by your average shop floor worker with minimal training? These are the kinds of things we want to answer for you. So like the title says, it is an intro. It's not especially targeted towards super experienced career metrologists and GD&T experts. So if you're a little new to this, you're in good company. If you are an expert and you have higher level questions, don't hesitate to ask them. We want to answer as many of your questions as possible. That's the most important thing to us today. We'll save the last 10 to 15 minutes for a question and answer, but you don't need to wait till the end. Go ahead and ask those questions as they come up, and we'll answer as many of your questions as possible as we go. That's why we're here. So before I hand it off, I'll say a quick word on hardware. I don't want to get too in depth because we've covered hardware multiple times in recent webinars, like 3D scanning hardware, how to choose it and use it. You'll find that webinar and lots of others if you go to the Hawk Ridge Systems website and click on the Resource Center at the top of the main page. So if you want to know more about which hardware is appropriate for which application, go check it out, or just give me a call, shoot me an email. My info will be up on the screen at the end. So for today, I'll just give a quick word on why we're using the hardware we're using, which in this case is a hexagon absolute arm. So Hawk Ridge, as you saw in the last picture, provides many systems that are suitable for inspection, as well as some that are not so suitable. And we cover the reasons why some are less suitable in that webinar I mentioned. But articulated arms like these are the most popular choice for general inspection worldwide for a few important reasons. They are fast, and because they have touch probes in addition to 3D laser scanning capability, you can extract measurements in seconds without post-processing scan data. They're simple to use with minimal training and suitable for use by non-specialists. They don't care what shape an object is, and they don't require prep like adding stickers. Lasers can scan shiny objects without the use of dulling sprays, and the touch probe can trace features like the thin edges of a sheet metal cutout that would be really difficult to capture with a scanner. So there are a lot of reasons why arms are so popular in QA. And with that, we'll go ahead and take a look at one. I'm going to hand it over to Matt Fisher, and he's going to show us what a typical inspection might look like and what are some of the features we can use to perform different types of inspection. All you, Matt.
Thank you, Ian. So I'm just going to show my screen. I'm also going to show my webcam so that way you can see the scanning in action. So you should see both now. So what I have right here is the absolute arm. So this is the CMM arm that Ian just mentioned. It has on top the laser scanner itself, and then we also have the touch probe right here. And what's really handy about this is it is based on a bunch of actuators. So essentially just like any other kind of CMM arm, we have a base central point where all the data is being sent to and processed. But because of that, we can move this in a whole bunch of directions and it remembers where its relative position is to the base. So because of this, we can be able, like Ian said, to just extract out dimensions super quick and easy using the probe feature. So what I want to like typically start off with when I start showing off that arm is something called the quick measure tool. And so if there is ever a situation, I mean, it seems like a lot whenever we work with CMMs that we're gonna have to set up a whole routine, but oftentimes an engineer might just walk up and or a machinist might machine a part and they say, we just need to know if this hole is the right size or these distances are right. Well, we don't have to pull up an entire inspection routine to be able to do that. Hexagon does have something called quick measure, which if I click on this option, see this little window pop up and it asks, well, what do we want to measure? So we have a bunch of different tools to measure with, and I'm going to choose hole diameter for one. So why this is super handy is because all we really have to do instead of setting up a whole routine now is using the arm, we can just probe a plane and then probe the hole that we want to project up to that plane. So if I have a situation like right here, I have a hole at the very top of this block. Well, I'm just going to go through, set it on, just click a trigger, grab a couple of points to define my plane, just about 4 points. And once I have that plane defined, I just flip a switch, and now it's going to start asking for that circle. So now I can go over, probe one part of that circle, and then maybe 2 more or 3 more, just so I can get a good definition of what this circle is. And this is something that anybody can do. As you saw, I didn't have to start any kind of inspection. I didn't have to go into any kind of special mode. I just had to click quick measure and have the arm available, and I can define out my circle right away. I know that the circle is 30 millimeters in diameter, so 29.99 is a pretty good measurement off of just a quick 7 points is all I really took to be able to start getting some dimensions out. And like I said, we can do things beyond that. So again, if we have a distance measurement that we need to do, I'll just click on distance measurement. And now again, if someone comes up and says, hey, we need to know that this part is the right length, well, I can just go through, define out one plane, flip my switch, and define out another plane. And these probe measurements are extremely accurate, and we have multiple forms of probes that we can get with the hexagon arm. So there it is saying 120 millimeters. I know that this is 120 millimeters in length, so that's perfect. The reason why it's negative is because I work backwards to forward, so doesn't really affect it too much. But like I mentioned, if we have different types of things, like maybe like a tube or so on, we do have different probe attachments that we can use. So this is a different kind of probe that we often will use to get inside of different areas. So we can do things beyond just the simple short probe points. But that's just a quick measure tool. That's just something I really like to show off just at first, but how about diving into actually setting up some kind of special routine? So there is software like PCDMIS, which comes with the Hexagon arm, which is their proprietary inspection software. But I am going to use Control X for this demonstration because Control X has a lot of extra tools in there, and it's a very intuitive design and easy to use interface. And Spencer will definitely talk more about that coming up. So what I can do is now that I have Control X opened up, I can import in my CAD body that I want and then start setting up my routine. So I'm just going to go over here into my import tool. I have a couple different file types. If I expand out this list, as you can see, we have a ton of different file types that we can import in, both measurement data and CAD data. In fact, we can even go right from SolidWorks files into Control X, which is really handy. But I'm just going to select on this IGES file that was used to machine this block right here. So it's going to bring in that CAD data, or it's going to come in and reference data right here. And now what I have to do is, again, this is an operator comes in, they want to set up their routine. Well, first we have to define where is this block in space. So as I mentioned with the hexagon arm, it's all based on a central point in the base. And because of that, we have to basically define where this block is in relation to that base. So one of the really handy tools inside of Control X, especially with things like the CMM absolute arms, is this ability to do a live alignment. So essentially, when I click a live alignment, we have something called adaptive, and it's going to do our alignment as we're probing our points. So it sounds kind of complex at first, but it's actually pretty simple and intuitive for anybody to kind of walk in and do. So I click on adaptive, and the first thing it's going to ask is, well, where are we going to start probing these points from? So if I rotate this around, let's say this is on a fixture, but for now, I'm just going to choose a couple points. So we're going to say, well, that's going to be my first point I want to probe. It's going to be my second right here, third right here, then like a fourth, and maybe even a fifth right here. So the more points you have, the better your alignment, and you'll see as I go that this kind of starts fine tuning and cinching in. And I'm just going to choose, about 7 points, just so that way I have a good spread on a couple different faces. And at this point, I can click OK. And now it's going to start asking to do the alignment itself. So if I am a different engineer, let's say I've set up this routine, this inspection part, and I move the part off and I give it to another engineer and they bring another part in. Well, the first thing that's going to ask is, okay, well, where are the defined points on this new part? We have to redefine them and align based on that. So I'm going to take out my scanner, my probe mode, and I'm just going to start clicking a couple of these points on the screen. So you're not seeing anything just yet. So there's one point right there. I'm going to do the second point about right here. But yes, you're not seeing anything just yet, but that's because it hasn't really defined where that spot is just, or where this thing is just yet. After 3 points, however, you're going to start seeing my scanner come into play. So now as I get closer, I can see exactly where that is popping up, both in the workspace, and I can see how that's comparing to my real life block. So here's the next point right here. And again, these are just routines I just set up on the fly, these points I chose. If I want to change this up, I could definitely redo this alignment to make a new form of alignment points. But if I wanted to replace the part with a different block of the same size and do the measurements and alignment again, I already have the routine set up. So all these points are set up on the new block and I just have to probe it in the new position. I'm just going to do this last probe point right here. Once this is done, we can even double check how close this alignment is by just hovering our probe over certain parts. Now this block was machined in some areas not to be exact, so this is good to see these different deviations, but as you see, these areas where I did kind of probe it in certain spots, they are pretty aligned. So now what I can do is if I maybe select on a different face, I can start just choosing a couple points and just jump right in to my inspection routine, not even having to switch out of this alignment mode because we're in live inspect mode. So I can go through and probe a couple different points if I want. And then once that's all done, I can just confirm it all and set my scanner back. I'm just going to back out of this live inspection mode so we can take a look at what we've done so far. And here's our block. It's now aligned to a new origin, as we can see in our corner. It's all aligned based on our new live alignment. And we even have definitions of where we probed it. So we can see, okay, well, maybe someone wants to walk over and see exactly where we inspected this and aligned it on. Well, we can see not only our align points based on these deviations right here, but we can even see those extra points that I probed myself. And all of this is listed right here in the model manager. Not only the session that we use for our alignment, but also all of those control points that I measured after our alignment. So I can see them all listed out. And then here is that adaptive alignment also. As I mentioned, because this is part of a routine listed in this drop-down menu, if I were to place this part, this adaptive alignment would say, hey, would you like to update it? And we can just jump right into the routine again with the new block. I'm just gonna hide all of these for now, just so that way we can clean up our space and then take a better look at this. Another thing we can do is we're not out of the woodworks if we just got out of that live measure mode and you have to add more points. We can definitely click this probe location button and just jump right back in to inspection. So this is going to create a new session. So now I can go over again, maybe probe a couple of points, and all this is going to be listed in a new inspection routine that I can bring over into my report. So I can confirm all of those. And if I back out of here again, I can see these comp 2 points, which are the new ones that I just measured. So again, ways to add new points in, super quick and easy, takes a little time to set up, and it's very intuitive. As you saw with that live alignment, it's even walking you through the alignment part, so anybody can pick up the scanner and know exactly where they would need to touch the control points and go from there. And as for actually probing it, you just want to make sure that the probe is neutral to the face that you're probing. But it's pretty easy to pick up. I mean, if I'm pointing at an angle and I'm touching the point, it might get a little bit off of a measurement because it's based on the central point of that probe, which is why you want it to be normal to the face. So I have all of these control points picked out, but what about actually something like a 3D scan onto here? Maybe we need a color map displayed on top of our block. Well, that's really easy to do as well. So thankfully with these CMM arms, all I have to do instead of unplugging a bunch of things and plugging it back in to switch from maybe a probe mode to a scan mode, I can take this off the arm or the base, hold down the trigger, click the button twice, and now I'm in a scan mode. And you can see this bar appear. On my hand, the dot means that I want this dot to be in line with the line itself. And I'm now in the scan mode. So now what I can do is I can just jump over into maybe something like live capture inside of Control X and start adding in my own scan data. So because this is already aligned, you'll even see as I go over this, it even knows where I am already. It already recognizes that these points are already aligned. So I can go through and maybe I'll focus on this top part. We have a pretty curved freeform surface here. Just adding in a scan. And I can get at a couple different angles. We don't have to do our alignment and then add in scans afterwards. There are ways to do multiple forms of alignments with just scan data. So you can definitely scan outside of Control X, or as you can see, scan into Control X, confirm what the scan is, and then it's going to give us a couple options from here. So from here, we can switch to a probing mode if we want to go back into probing a couple of points. We can exit the live capture to see our data from a different perspective back in the main menu. There is this mesh buildup wizard, which allows us to actually take all that scan data and convert it into an actual mesh. Or we can change the position, add an extra scan, and then go into that mesh buildup wizard. So we don't have to just stick to one single scan. And like I said, we can also exit out of this and bring in our own scan afterwards as measured data. But here are that scan data is popping up into here. And if I zoom in closer, we can see that it's already been aligned. So now what I want to do, if I want to get a color map from here, is I can go into compare, and then I have the 3D compare option. And I can say I want to use all the data that I've used so far from my different scans. And I also have this ability to select individual surfaces that I want to focus on. So maybe, like I said, I want to focus on this freeform area. Well, I can select in all these individual little faces, just like this, maybe even a box selection if I want to get multiple ones at once. And from here, there we are, I can click this next arrow to get a preview of what that scan will look like. And already, in just a matter of minutes, we've aligned our points. We can now extract some new probe points from it if we want. And we have our color map that we can just start highlighting over, selecting on a couple of areas that we want to maybe focus again on or display it out into a report. I can select on that just as well and confirm this. And as mentioned, if we want to go a little bit further, if we do want to scan directly into Control X, we do have inside of the live capture, we can capture a couple of different points and then go over into our measure tool and use the mesh buildup wizard. So there, like I said, there are ways to get that mesh data right from the scanning in here. With that, however, I did want to just go over a brief introduction on what we can use the arm to quickly get our probe points and maybe even some scanning in. But that, again, this is pretty surface level. I'm going to transfer it over now over to Spencer, who's going to kind of show more about the in-depth tools that you can use now that we have something in here. Maybe there's a couple different comparison or alignment points that you want to use, or maybe you want to use a couple series of data and actually generate that report. Spencer can definitely show that from here. So with that, I'll take it away, Spencer.
Thank you, Matt. So as he was talking about here, right when I open up Control X, we're prompted with this user profile. All right, so as you can see here, operator, basic, and expert. So the operator would be someone on the shop floor acquiring the measured data. You know, he's not going to be really doing much of the per se the programming or making the designs, but he'll be the one operating the scan arm or your handheld. When you go into the basic, this is more of a workflow that has limited amount of tools just for what is needed, and then expert is all the tools combined. For this, I'm going to turn it on to the expert. And as you can see here, I have a CAD model and I have measured data in the blue. The goal here is to bring the measured data to the reference data. So then I can do, just like Matt did, we can do 3D compares, we can do cross-section compares, we can do comparison points, and so on and so forth. So you'll see here in my home tab, we made it really intuitive. So we did a left to right workflow. So basically everything I need here, I can bring in, I can import measured data, I can do all my alignments, my comparisons, and then I can also do some dimensional stuff. Right off the bat, what I want to do is I want to use this tool called an initial alignment. And what this will do is it will roughly align the measured data to the reference data. So let's run that. Right, and now that you see I'm aligned, I would want to do a more refined alignment. So I'm gonna open up the best fit alignment, and what the best fit alignment will do, it will give us the overall best fitting of this measured data to the reference data. I can also in this section use selected data only. So let's say I just wanted this face, this bottom mating plane, and maybe this cylinder to drive my alignment. I could do that. For this demo, I wanted to go more into maybe a datum alignment. So let's say my drawing has this bottom mating plane as datum A, maybe this inside cylinder as datum B. Let me turn off my measured data there, but then I'll have that and I'll hold shift and click on this. And then I'll use this last mating plane as datum C. And typically I would change my iteration count to 25. The iteration count is how many times the software is going to try to go and find that best fit alignment. And we'll let this run. So now that you see we have a more refined alignment, and I have some values here too that will be reported in the final report, I'm going to hide this. And what I would typically do at this point is I would start a 3D compare just like Matt did. This is very good for first article inspection. Let's say I have a part and I wanted to take it off the line. I could come in and scan it and then do a really quick analysis to see how well we're manufacturing things. So let me say next stage here. Something Matt didn't go over in his presentation was obviously all the tolerances could be changed pretty quickly. If you are interested in using a different color map, so a lot of people like to use, this more rainbow style to see where they're getting close, or they like to use more of a pass or fail. So that's really easy to toggle in and out of. And at this point, we have these tagging. So if I wanted to turn on the 3 oversized tags and the 3 undersized, so the 3 low, I can easily do that, and then I can actually pick in this order too. So at this point, I would accept this, and you'll notice if I click on this and down in my result navigator, this is what you're going to see in the final report. So, I think it's a little more important to get maybe this angle. All I have to do is say reassign the viewpoint angle, and this will now be generated with my tabular view down here as well. So typically the next stage after that is I would find a place on the part that looks kind of, a little suspect to me, and I would open up that 3D comparison point tool here. One thing to mention, right, we can manually just pick points on here, or we can do more of a pattern. For this, I'm just going to manually pick a few points on that surface area that is a little scary to me here. So let me grab that, grab one here, here, and then I'm going to actually kind of move my own tags around. So this is really a really fast way to show to people that, hey, we need to either start worrying about this, or this is something that we want to keep an eye on here. So, and then also, just like before, all of our tool tables are pretty much the same in the aspect where I can easily change the tolerances that we are looking for here. So at that point, I would say okay again. I would turn these comparison points on with my color map. Let me turn these on, and as you can see, these eyeballs are really easy to turn some of the annotations on and off. So if I click on here again, make sure my points are showing. I'm gonna then say reassign that viewpoint, and this is what will be then brought into the project. Right, and then also with these comparison tools, we can use something more along the lines of a 2D compare. So if I wanted to say, let's see what the middle of this cylinder looks like, we can come in here, use one of our offset planes, which I believe is Z, And then I can actually scroll into the middle, or I could give it more of a numerical number there. But at that point, that looks good to me. I'm going to say next stage. And at this point, this might be a time where you would like to see more of a pass or fail. So let's say, okay, pass or fail. So here we can have our oversize and under tags again. And you can see how easy this is to set this up. You know, in a few hours, you can pretty much be an expert on learning how to do the 3D compares for first article things. But once I'm set up in this, now typically what I would suggest to do is now we go into more of a dimensional analysis. So let's say I have a drawing and I need to, I need to see the linear dimension of this entire part. I need to see some radial dimensions, and then maybe some linear dimensions from this. We have a really fast tool called the Smart Dimension tool. So what I can do here is I can really quickly add dimensions to this reference. There it goes. So right there, I can add that. And without switching from this tool, I can go into this radius and the software will recognize that I want to take a radial dimension on that. Same with this. If I click on my cylinder here and I click on the cylinder over here, the software will allow me to say, hey, this is, he obviously wants to have a radial dimension here. This is, I could do at least 100 dimensions here within 5 minutes just with the Smart Dimension tool. We can also then come in here and right click on this and say edit annotation style and say more detailed. And as you can see here, now we have a more detailed annotation there that will then be prompted into the report. So at this stage, we could keep adding those dimensions, or we could run a more of a GD&T sort of analysis. Typically, people only really need dimensional stuff, but sometimes drawings call out the GD&T stuff, so we're fully functional in GD&T. The way we run this is I would have to set up a datum. So let's say I want the concentricity of this cylinder to that. So I would say, this is my datum A. Say OK. Let me make sure I'm showing that. So now we have a datum A. So what we need to do is we're referencing off of this datum. So if I open up concentricity, I would say I want to use datum A and take the concentricity of this cylinder, right? And at that point, we can change our dimensional tolerances as well and say OK. So once I'm done with that, once again, I would probably want to orient my part in a fashion that I can show, a really nice depiction in the end of what I'm trying to show. So I can then change out that. I can come into my CAD here and say a little more reference there where I can see this, and click on GD&T group and say group 1 with my annotation showing and say reassign viewpoint. So at this point, what I wanted to show is within the last 13, maybe 14 minutes, I set up all my inspection plan that I wanted to do. What I want to mention here now is that I could have done this without. I could either have done it two ways. I could have done it with the scan data already, or I could have done it just with reference data and then imported scan data and then press rebuild. So there's a few different ways to go about inspecting things. Another really cool functionality here is I only really have to set up this inspection plan one time. So if I click on here, I can actually say replace measured data, and the software will then come in and re-import that scan data, and then it will say regenerate itself. So the reason why this is really cool is if I have tooling, or if I want to know some batch analysis functionality, I will actually track my different inspection plans. And so for like a tool, for instance, I could see where, and before I have to take that tool off the line, I can say, hey, you know, I see this is going to probably fail soon. Let's make sure we deal with this now. So we see a lot of people using that for that sort of functionality. But like I said, right, so we only really have to set this inspection plan up one time. So going from here, now it's time to generate a report. So I'm going to come into my tools here, and I'm going to say generate report. Right, and so you'll see here that these are our selected items, and this is these are our tree items. So for instance, I don't want this initial alignment in my tree. I can easily move that over, and then I can also, you know, change the order of these entities as well. I'm going to add a 3D PDF page, which is cool function. If you have the Adobe, you can actually toggle around within the 3D PDF. But I want to mention too, now with 2020, we have a free viewer, so everyone in the company can have Control X on their screen or on their PC. You will be limited in functionality, but you can look over, you can interact with the report there. So I'm going to say all right there, and I can say generate, and you can see how fast this report is then generated. And let's say I come down, let's say I come into this area, and for instance, this first 3D compare one, you know, I might want a better a better angle there. I can always come back into the report and say, you want to turn this on, turn these off, right? And then orient it in a little better fashion. Right, and say reassign down here again. And now when I come back to my report, I can rebuild that as well. So at this point, you know, I want to hand it back off to the guys at Hawk Ridge. We're here to answer any Q&A questions if you have any. And then we're more than welcome to, you know, on a sidebar, answer some more questions on anything that you might be curious about there. So I'm going to actually switch over back to Ian here.
Big thanks to Matt and to our guest Spencer. Thank you both. Big thanks to all of you for joining us today. If you want to dip your toe in the water with some services, we do provide services. And if you have questions, if you want to see a demonstration on a specific topic, hit me up. We want to hear from you. Thanks again. See y'all next time.